Hello all, my name is Pradeep. Welcome to my YouTube channel. So in this particular video, I have done a Kaggle problem statement which I have completed and submitted it. But still, it is in an initial stage, but I need to hypertune it and apply more proper algorithm and play with each and every parameter. And apart from that, I have done future engineering, future selection, simple model creation is done, and I got a good rank for my result too. Basically, I'll show you what you have to do in Kaggle. So here I'll tell you what is Kaggle, how dataset is present, after programming, how you need to submit your dataset. So all these things will be covered now. So let us begin. Now let us take house price advanced regression technique problem. So we'll start with the description. So description, we have a basic idea about this project, and next we'll move with evaluation. So evaluation is through this root mean square error, your predicted result will be evaluated and your rank, you will get your rank. And in this tutorial you need to know some basic algorithms to get started with this project, and those things will be given here. And the very most important thing is, guys, data. So you will have a train data, test data, and here you can see how your data set is present. So this is your train data, so where you will have a number of fields, and just will maximize the view. So this is your training data, where you will have different fields, and you will have all these values, and moreover you have 81 fields in this training data. Fine, guys. And at the same time you will have your test data. So what this test data is used for, actually what this training data is used for, basically training data is to train your model in this data, and test data is after training you have to test this data, right? For that you will use your test.csv data. So whatever output you are getting, you have to submit in a sample submission.csv. so this is what the format you follow when you submit your result. And you can able to see a common thing between a sample submission.csv and the test.csv. what it is a common thing between this is, you will find id, which is unique identifier. You can see this id, guys, which is unique identifier, which is common for both these sample submission.csv and test.csv. and the next thing is, we'll see what is leaderboard. So leaderboard is, you can see so many people's got very good rank here, and one of mine is yeah, you can see here. But still I have not done hyperparameterized optimization. So far 4000 plus people have participated, and almost this is my first problem solved in Kaggle. So now we'll download the dataset and we'll start coding. So to download, you just see a download all button, just click this, so all your files will get downloaded. Now let's code now. So this is I'm using Jupyter notebook for this, and basically, guys, I have installed some basic libraries: pandas, numpy, cborn, matplotlib. And here I have, you can see apd.read csv is, I have got all the data, and I have stored it in the form of data frame. And this is how the data looks like, guys. You can see here all these are field names, and you can see the sales price which we need to find. So we'll next get to know what is the shape of the data. You have 1460 rows and 81 columns, and that's all about, getting to know what the data is. And the next thing is, we'll deal with some missing values. So that is what we have to do first. So for this, I'm just calculating how many null value are there in my data set. So I'm using df.snull.sum. so this will give me a field that contains how many null value. So what you'll do is, now I am getting this info is what, nothing but is, we'll be getting that particular data set, particular data type of that column. So this is what, if say suppose if there is an ms subclass, if this is the field, this is in data set, in data type. So this is what we will be getting. These are all some basic things which we need to start before future engineering our model. So here, as guys, I have taken all the null values. You can see I have taken all the null values. Here is lot frontage. So what I have done is basically what I will be doing is I will be replacing the mean value to that null value. So what I'll be doing is I'll be doing df lot frontage dot fill na df lot frontage dot mean. So this mean value will go and get replaced in the null value. For that purpose we use fill na, and here you can see that I have dropped the whole field. Why? Because see this is the field which I have dropped now. Why? Because see, almost we have only 1460 rows, whereas here 1369 rows are null. So there is no use of handling this data. So if the percentage, if it moves more than 50%, I would have dropped it. So this is how I have future engineering line by line, that is future by future I have implemented it. Simultaneously you have to handle this for your test data too. All future engineering doing is for training data, you have to do it for your test data. So what is this test data, and in what way this training data and test data get differs? We will see that. See guys, in this is our training data. In this training data, the shape is 1460 and 81 columns. This number of rows, it doesn't matter, but the number of columns is number of fields that really matters, guys. I'll show you why. See, this is the test data. Here, like same, I have implemented the basic libraries and I have converted this file into a data frame. I am seeing how this data looks, and here you can see, guys, you will not have any sales price, whereas here you can see you will have this sales price field. So why? Because this test, why? Because you will be after training you will be testing your data here, so you will not have that dependent variable over here. That is the major difference for your train data and test data. And so here likewise I have done this future engineering for each and every row, by future I have done this future engineering. And if suppose every time after implementing more, and if you want to go and check like this the rest of the null, how many null values are there for rest of the fields, instead of that you can use your heat map to get how many null values are there. So I have used Seaborn for this. So by doing this I can able to see how many null values are they still exist in the column. So still this is bf fin type 2, so here there is some null value, so I am implementing more. Why? And I'm just implementing mean and mode, right? So mean in the sense I will be using it for integer purpose, whereas mode I will be using it for categorical purpose. So even it will find the major part of the category and replace it with the null value. So for that purpose I am using mode. And finally I am looking for this heat map. There is no null value, so now I am checking the shape. It's 14200 rows and 75 columns. Great. So now what we'll do is we'll further move with we'll move with statistical analysis, guys. So this is the very important part, and here now we'll handle some categorical features. So I'll get the column that is object type. So here I'm getting the column only object types column. So you can see here these are all the object types column. So object type is nothing but these are all the columns which undergo categorical features. So I'm getting this column alone. See guys, why I'm doing this, see, say for example I'm taking this BSTM con, right? See, in this training data if I in this training data, if I have 3 fields for this BSTMCon, whereas in this test data I'll have 4 features for that BSTMCon. So when I'm using pd.get dummies, in this 3 future I'll be getting out of 2 future when I implement pd.get dummies, whereas here if it is 4 features I'll be getting 3 categorical values by applying pd.get dummies. So I might able to miss some of the value. So for that what I'm doing is I'm getting this for that what I'm doing is I'll get this column, I'll get this object type columns, and what I'll do is as I already discussed with you, so even in for test data we'll be future engineering for each and every future. See guys, I have done for all the futures line by line, and what I'll do is I'll just save this data set into a CSV file with the name of formulator.csv. So what I'm doing is, after saving that file, what I'll do is I'll get that formulator.csv file as a data frame here. So what the end result, what I'll be doing is this, when I'm using dummy, it will be a huge problem here. So I'll take the test data concatenated with the training data. So here you can see I'm just concatenating the training data and the test data. So after concatenating, I'm just seeing this sales price alone. Why? Because usually the training data, it does not contain any sales price. So what it will happen is, after concatenating, if after training data the test data gets concatenated, so that for that test data the sales price will become null. And this is the most important function, whereas I'll be calculating get dummies for both training and test data. So the reason is, after concatenating I can apply pd.getDummies, which convert one hot encoding to the entire column. If it combines, I will have all specific number of categories which in each and every futures, and it will never increase after that. So I'll be covering all the futures. So I may not have, in future I may not face if there is any future missing, or if there is any additional feature is missing, or so finally what I'll be getting is all the data frames concatenated with this categorical features. So this is what the final result I'll be getting. So this is the function, and I'm using to guys, only this object type I'll be implementing for this function, whereas that is the categorical features. So after implementing, definitely I'll be having some duplicate values. So what I'll be doing is, I'll remove the duplicate value from my final df data frame. So here all the duplicate values will get removed, so I'll have only the unique values, and here almost my future engineering is over. So here what I'll do is, and guys, remember, in test data I don't have a sales price. While concatenating I'll have a none value. So what I'll do is, after removing the duplicate, what I'll do is, in the sales price I'll in the test, and here I know I know the count, guys, how much is test data and how much is training data. So what I'll do is, I'll separate this training and train data and test data, and I'll just check the shape of the training data. It's 1422 rows and 175 columns. And whereas in test data, almost the sales, we should not have the sales price, because we need to test the data. After training we need to test the data in test.csv. So what I'll do is, I'll remove the sales price over here. So now the training data shape is 1422 rows and 175 columns. So after, I'll just get my x and y value. So after getting x and y value, I am implementing XGBoost algorithm. See guys, I could have used linear regression and some other algorithm, but why here I am using XGBoost is, it implements gradient boosted decision tree designed for speed and performance. And this is, and you can use you can use unstructured and tabular data. So that is why I have used this XGBoost, and I have created an instance So and here I have completed my model, and using this pickle file I'm getting my I have used pickle here. Why I have used pickle is to retrieve the file like what we saved, so that will be in .pkl extension. Fine guys, and here I am predicting my test data. See, as I told, so for prediction purpose we will use the test data. So I am getting this prediction value, which is the sales price value. So now what I will be done, and here is the final part where we are going to submit the result. So here I'm getting this PD data frame ypred. So this result I'm converting into a data frame, and I'm getting this sample summation.csv file, and I'm storing this in another variable. So I'm creating a new variable and I'm concatenating this. I'll have an ID in this sample summation.csv, right guys? So I'm getting this ID and I'm getting this predicted value. So I'm concatenating these two into a new variable as a data frame. So I'll concatenate and I'll save it, and I'll give the heading for that column name. So I'll give column as ID and sales price. Now what I'll do is I'll convert this dataset into an sample summation.csv, whereas like how we discussed, we'll have this we'll have this output like this. So after getting our file, I'll show you how it is saved. See, this is how the file is saved now, and it's taking some time. Yeah, so you can see here the heading is ID sales price, and this is how my end result will be. And my simple model creation is done, and I have completed my project. So what I'll do is, after doing this, I'll click this submit prediction, and here I'll upload my sample.csv file. Once if it is done, you automatically it will calculate the evaluation is done by means of this root mean square error. So after this, your result will be given for you in this in the leaderboard. That's all guys. So in this video we have covered how to start with this Kaggle problem, and after completing it, how we should submit and see our result. And here guys, I have implemented a very basic feature engineering, feature selection, and I've created a very simple model, and still lot more need to be done. So that will be done in my next video. Thank you so much.